Hey everybody, this is Larry. This is me going Q2 of the weekly contest 436. Assign elements to groups with constraints. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about this one. I think the trickiest part about this one is there are two parts, I suppose. So maybe I lied by saying there's only two. But the two tricky parts about this one is that groups and elements are big, right? So you can't just do like a cross product type thing of like, okay, for every group, or like a double for loop, right? That's too slow, obviously. The first thing you need to know about this problem is this idea of SIF, right? You may not need to. I did it with SIF, but of Aristoteles. I always say it wrong. Look, you have Google. I have Google too. Hang on. That actually is someone else, but apparently, Eratosthenes. Okay, fine. Anyway, the Civ. Not to become confused with Civ, like civilization. Civ 7 is coming out. Or is it already out? Maybe. I don't know. Anyway, okay, let's focus on this, Larry. Civ, right? Anyway, you don't need to know particularly the Civ per se, though. I mean, for this problem, but you probably should know it if you are looking to solve. Though for Q2, this is a little bit hard if you ask me. But in any case, yeah. So you're given the SIF, right? And the key part about this idea is that, if you ask me, the core part that you have to know about this idea is that if you do a for loop, right, like for I in range of some number m all the way to m, and then now you loop from I to 2 times I to 3 times I, dot all the way to m. Well, then you, in this case, then if you do for the number I, you do m work. For the number, for number 1, you do m work. For I is equal to 1. 2, you do m over 2 work. 3, you do m over 3, right? And then dot. So then you have the summation of m plus m over 2 plus m over 3 plus m over 4 plus 1, right? And it turns out that this is going to be this is m log m, right? The prime version is a little bit different because you only do it for prime numbers, for example, so you don't do it for 4. So it's a little bit faster, but there are, we don't have to talk about that for now, right? What I mean, what I need here is that this summation actually has to m log m. That means that if I'm able to have this kind of structure, I hesitate to call it pattern, but it's just like a tool in your box, right? Where if you have m and you're looping from I, 2 times I, 3 times I, so forth, and you write it actually like, well, well, no, not I, maybe like j, right? J is equal to I. So we have these two loops, right? It actually runs in n log m, or m log m, which is important. And then after that, once you realize that, then you're okay, right? So that's basically the idea. There are a lot of ways you could have done it, but honestly, for each element, the key thing to note is that for each element, you just make sure that you don't duplicate your work. So that's the key part about this for me, in terms of proofs. I mean, maybe there are other key parts, but if you don't duplicate your work, then it'll be m log m, right? Or m log m, right? And the reason why that is the case is that you can, if you do duplicate work, then this kind of falls apart, right? Because you can just give it all once. If you give it all once, I mean, yeah, maybe you could do some if statements, and maybe, but you have to be really careful with a lot of stuff, with some ad hoc rules. But if you repeat numbers, then this is, instead of this, then, well, if you give it all once, for example, then it will just be very simple to do, right? Which is equal to m squared, right? So you can definitely do that, or n times m or whatever, depending on how you want to write it. But yeah, so that is definitely, obviously, no-brainer, right? So, but that's easy to fix. That's easy to solve. So we just have a done thing, and if we already solve for this number, then we just continue. I think there are a number of ways you can do this. For example, you maybe could sort the elements and then just go from small to large or something, and then take the min of the indexes. But I don't know, I like this way a little bit more. You don't have to worry about min. So yeah. So then if we already finished this, then we don't. And also the other thing is that if you already finished this, you don't want to do it anyway because it cannot improve your answer if you do it in the order of the indexes, right? So here, if you can save work that way and also create a proof for your upper bound, which is, for me anyway, more important during the contest. And then this is the general CIF. You can maybe write this up here. And then this is just a general CIF. And then best subkern is just the first time we see this number. If it's -1 is the first time, so we set it to the index that we want to look at. And this is regular CIF East problem. So then for every number, we just set it to that. And then at the end, for each number in group, we just gave it the best number for that number. Like I said, there are other ways that you can kind of have the same idea, but I think they're all going to be very similar. And also, as I said, as a result, this is going to be M log M, where M is actually not either of those sizes, but the maximum number of bits kind of, or the range, which in this case is actually 10 to the 5th, which actually kind of matches the other numbers. But yeah, also elements as well, but that part actually is not as important as the groups part. But yeah, that's it. And it's gonna be M log M, where M is at most what's it called, 100,000, right? So yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, you could watch me solve it live in the contest now. Okay, really annoying Q1, but not too bad. Focus. All right, let's go. Whew. Groups. I'm gonna check. So confused. I don't even know what it's asking for. Zero, 1, and 4. Okay. This is so confusing. Okay, so 4. So n times y is going to be too slow. I guess that's the kick, right? Okay, so then we in theory it's just loop spit. I mean, I know it's just ultra-McCoy, but It's kind of hard for a Q2, huh? Am I confused about this problem? Maybe, huh? I guess, am I just thinking of a dumb way? I don't know. Maybe this will time out and I'm being dumb, but I don't know. Maybe I am thinking of a dumb way, but yeah, I don't know. This is such a crazy way to do it, though. Yeah, I don't know. Is this fast enough? Honestly, not sure. Because it depends on their input. It's a little bit. I mean, I know it's m log m, but wow, 2 hearts. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, this contest, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.